Show that a quadrilateral is a parallelogram. So our learning target for this lesson is to determine whether a quadrilateral is a parallelogram using a set of given conditions. So if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if AB and CD are congruent and BC and AD are congruent, then ABCD is a parallelogram. Okay? Angle measures. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. Okay? If one pair of opposite sides are congruent and parallel, then the quadrilateral is a parallelogram. So notice BC is congruent to AD, but it's also parallel. So since it's also parallel and congruent, then I know that ABCD is a parallelogram because it is parallel and congruent. And last, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So understand that if they bisect each other, then BD is going to be split into two pieces, and AC is going to be split into two pieces. And this point right here where they bisect each other is going to be the midpoint of both of those segments. Okay, so let's identify our parallelograms. And then we want to explain how we know that QRST is a parallelogram. So I don't know anything about the side lengths. I don't know if they're congruent. I don't know if they're parallel. All I've been given is angle measures. So if I look, I need to figure out what angle S is. And this is a quadrilateral. So I know that if I add all of my angles together, so angle Q plus angle R plus angle S plus angle T, that they should equal 360 degrees. So because they should equal 360 degrees, I can substitute what I know to solve for S. So Q is 67, R is 113. I'm not really sure what S is yet, so I'm going to just put S. You could also put a variable. And angle T is 113. And all of them added together equal 360. So angle S equals 67 degrees. So this is 67 degrees. That means that both pairs of opposite angles are congruent. So therefore, QRST is a parallelogram. All right, let's look at the next one. So in the next one, I am given nothing about side lengths again, nothing about angles. However, I have been told that QP is 3x and SP is 3x. So that means that these two segments are congruent. And I know that TP is 5x and RP is 5x. So these two segments are congruent, which means the diagonals bisect each other. So QRST is a parallelogram. All right, moving on. Example 2. So what value for x makes FGHJ a parallelogram? Well, I already know that FG and JH are parallel. In order for this to be a parallelogram, these two sides also need to be congruent. So I'm just going to set them equal to each other so I can solve for x. So make sure you distribute your 4. We get 4x plus 8. And then x is equal to 6. And then we can double check by plugging it in. If x equals 6, then this would be 32. And 6 plus 2 is 8 times 4 is 32. So they're congruent. So now in example 3, I want to use coordinate geometry to show that quadrilateral WXYZ is a parallelogram. So I could either prove that both pairs of opposite sides are parallel. I can prove that both pairs of opposite sides are congruent, or I can prove that one pair of opposite sides is both congruent and parallel. So I'm going to start by finding out some information about WX. So the slope of WX is, my rise is 2 and my run is 1, 2, 3, 4. And actually my rise is -2 because it's a negative slope. So I'm going down. So -2 over 4 gives me -1/2. And then my length of WX, I can use my distance formula, which is very similar to the Pythagorean theorem. And since this is the length I'm looking for, this is my hypotenuse. So I can say -2 squared plus 4 squared. And then I want to take the square root of that. And the square root of that would give me the square root of 20. And you can simplify this if you want. It's good practice. Get 2 root 5. But really, we just want to make sure that the two sides are equal. So if whatever's under the square root sign is the same, then the two sides are going to be equal. All right, so I did WX, and I found the slope. And my slope is -1/2. And I found my distance, which is the square root of 20. So now I'm going to do ZY. So ZY, my slope is down 2 over 4, 1, 2, 3, 4. So this is -2 over +4, which gives me -1/2. And my distance is this length right here. The length of ZY is going to be the square root of negative 2 squared plus 4 squared, which gives me the square root of 20. So my slopes are the same, my lengths are the same, which means that I have one pair of sides that is both congruent and parallel. Now this should work with the other two sides as well. We've already proven that it's a parallelogram, but let's take a look. If I find the slope of ZW, I can see that that's a positive 2, 3. So my slope of ZW is positive 2/3, and my slope of XY is also positive 2/3. So ZW and XY are also parallel. And then if I look at my length, I can find the distance of ZW is the square root of 13, and the distance of XY is also the square root of 13. So I can definitely say that this is a parallelogram because WX is parallel to ZY, WX is congruent to ZY. Additionally, ZW is parallel to XY, and ZW is parallel to ZY. So both pairs of opposite sides are parallel, both pairs of opposite sides are congruent. So I wrote parallel. If I said parallel, I meant to say congruent. Alright, so go ahead and practice these few problems at the bottom and ask me any questions that you have about them. So in number 1, the diagonals bisect each other. In number 2, both pairs of opposite sides are congruent. In number 3, both pairs of opposite angles are congruent. And in number 4, I have one pair of opposite sides that are both congruent and parallel. In number 5, what value for x makes the quadrilateral a parallelogram? If x equals 1/2, then that means my diagonals have bisected each other. So that would make it a parallelogram. And in number 6, I wanted you to draw out your image. I chose to use sides LM and NO, but you could use the other two sides if you'd wish. I found that the slope of LM and NO were congruent, so that meant they were parallel, and that the length of LM and NO were also congruent. So therefore, I have one pair of opposite sides that are both congruent and parallel. So therefore, LMNO is a parallelogram.